Okay, so this is, am I audible to all?
Yes, Sajita.
Yes, so, okay. Okay, hi, this is Ajita from Siki, and I would like to welcome our chair, Henry Joshua, from our EV committee, and he's the head of our business development analog devices. And I also welcome Kalevani ma'am, the speaker. She's from Tata Consultant, and she's also the member, education director from EV committee from Siki. So I would like to held this meeting to ma'am. Please go ahead, ma'am.
Thank you so much for the wonderful introduction, Ajita. And to
Thank you,
add to
ma'am.
whatever Ajita told, as part of the EV committee, and this is one of the initiative from Henry, who is the chair of SICI EV committee. So EVOKE, which is nothing but electric vehicle open knowledge for everybody, uh, aims at educating on all the development activities in and around electrification area. So it is like for it will help fostering a very good environment. I mean, a kind of a growth market, especially in Tamil Nadu, and also like we will be bringing all the international um, market statistics also, so that it will help all the participants to get benefited. And also, like there are certain attributes and parameters that we will bring in as part of these sessions, which will help even the research students to start their research in one of these topics. So this is the ultimate aim of this evoke session, and we would like everybody to be active and participate. I mean, actively participate in all the sessions, and raise your Q&A at the end of the session, so that even Henry Joshua will be available till the end of the session, so that he will be able to take up Q&A and will be able to give you answers for all the queries that you guys have. And also, like if you guys have any other questions, even you can drop a mail to Ajita, who is the communication spoke for Siki, and she will be able to direct you to the right committee member. And thank you. And let me start with the session. So today's topic of discussion is more about how the electric vehicle can be handled. What are the first maybe I'll give a glance about what are the battery trends in the current market, and what are the safety mandates that an electric vehicle owner has to take care of, so that the number of battery fires and other mishaps connected to the electric vehicle can be reduced. So these are the topics of discussion for today. So a quick introduction about the topic and the difference between IC engine vehicles and electric vehicle. I'm sure that many of you, not all of you, all of you are from electrification background. I do understand that few folks are new to this domain and wants to learn from the basics. So we will cover from the basics for all the evoke sessions. So we'll just give a quick glimpse about electric IC engine vehicle and electric vehicle, what is the technology change, and then the battery trends and packaging, how the battery chemistries are packed in a way that it is safely used in electric vehicle, the battery testing methods, and how the battery fire happens, and what are the mechanisms, standards and regulations available in India, and how is that we can reduce the number of battery fires by optimally utilizing the electric vehicle. This is like creating an awareness will definitely reduce or make the owner, the electric car owner, to be more conscious of how he is using the vehicle, and also like a few of the future electric vehicle batteries, and then a quick summary of all that we have got today. So when we're talking about electric vehicle, it is definitely not similar to the current IC engine vehicles. So it is completely a different technology, where the components that we use for propelling the vehicle itself is completely different. So in that case, there are a lot of standards and regulatory bodies working on standardizing these modules or the components in a way that they will ensure the maximum safety is achieved in the electric vehicle sector. And when we are talking about electric vehicle sector, it is actually, it is evolving faster. It is not just the lithium ion battery or with cobalt that we were using before. It is like, it is just evolving faster in a way that there are multiple chemistries available, and each chemistries, how is that the regulations are applied for those batteries, and even a different battery technology itself, because the ultimate aim here is to propel the vehicle through electric, which means the motor is going to get the power to propel the vehicle, and the power source is going to be the battery. So this battery can be anything. It can be a lithium ion battery, or it could be any other form of the battery also. Even fuel cell vehicle is another kind of source using which a battery supply, the power supply can be given to the motors to propel the vehicle. That is also one of the way. So these are like the ultimate focus is on improving the testing standards for these batteries. Today we will mostly talk about lithium ion batteries. So some testing standards for improving these safety measures for these batteries, and fire safety aspects, like as a owner, what are the aspects that he has to take care while handling the electric vehicle. So these two are the main topics we will cover today, whereas there are other regulatory standards are also in progress, like battery disposal and recycling, end of life management of batteries. So all these are like we will cover in the subsequent EVOKE sessions. Based on, because of the time constraint, we will just cover only the testing standards and fire safety aspects today. So what's the difference between IC engine vehicle and the electric vehicle powertrain? Of course, that's a huge technology shift. If we talk about IC engine vehicles, it is going to be propelled by an engine and with one of the fuels, like be it petrol or diesel or gasoline. So by burning this fuel, it is going to generate the energy, and it is going to be transformed. Transmitted to the wheels through a transmission system, and it involves a lot of mechanical moving components which dissipates a lot of energy in terms of heat. In therein, the efficiency of the fuel consumption is not up to the mark. So that is the reason, that this is one of the reason. Another thing is like the exhaust system, right? The tailpipe emissions that are given out by each of the IC engine vehicles. If we have some 100 vehicles in an area running, how much you can figure out, like how much is the tailpipe emissions caused by so much number of vehicles. So it is we are causing a huge environmental damage and irreversible environmental damage, that is obviously connected to all the climate change issues. So all these are the few of the aspects that made the industry think about bringing in more of electrified vehicles. It is, of course, it is not a complete replacement of IC engine vehicles. It is like accommodating the electric vehicles for now, and experimenting more on the evolving battery technology, so that definitely the everybody knows that the battery pack is going to consume like 40% of the price of the vehicle. So as and when the battery technology evolves, definitely the price of the battery is going to come down. So, and also like one another important factor is there will not be any tailpipe emissions, because the battery, the propulsion is through electricity, and the electricity comes from one of the power plants. It could be thermal or nuclear or renewables. Of course, that we will see a couple of items in the subsequent slides, and we do have certain measurements like liters per kilometer. That is the mileage measurement for IC engine vehicles, whereas battery electric vehicles, it is going to be how much power per kilometer is being consumed, is what we use as a consumer. This is what my measuring parameter would be. So this is one of the well to wheel analysis result. Probably, what is well to wheel analysis? Well is nothing but the fuel. From fuel to wheels, how much is my energy getting transmitted? So how much is the efficiency? How efficiently I'm using the fuel to propel the vehicle? So that analysis was done with with IC engine vehicles, as well as with the comparison is done. This gives a comparison between the IC engine vehicle and the battery electric vehicle. So the first one is like usage of gasoline in IC engine vehicle. We could see that we have consumed around 8.9 million barrels of gasoline, and we could able to convert that to the energy to the wheels only with 1.8 million barrels of gasoline. The rest of the energy is completely dissipated as heat, and then it is actually, we call it as inefficiency loss, which they have mentioned it as 80%. So almost only 20% of the energy is being consumed efficiently. So the resource management here, it's very pathetic. And of course, the ICE engine vehicles cannot be completely replaced, but the alternative vehicle, the energy vehicles are analyzed here. Here we can see that replacing this particular study is on the thermal power plant, wherein with the coal thermal power plant, they could be able to achieve an efficiency of the loss is actually reduced to 68%, frankly speaking. Whereas in the battery electric vehicle, it is going to be continuously constant. The efficiency of electric vehicle is going to be consistent around 89% here, because the loss is termed as 11%. So the efficiency is going to be around 89%, and it is consistent across all these study, because the source, which is nothing but the power generation part alone, is just replaced with multiple other fuels. So here with coal, we could able to reduce the loss by 68% from 80%. With methane gas, we could able to reduce the loss to 56%. Whereas in hydropower, the renewable source, right, be it wind or solar or hydro. So with one of the renewable powers, of course, the loss is going to be zero, because the energy is produced by the naturally available energy resources. So that's the reason the loss is very minimal. And we could see that inefficiency loss is also 11%, which means the efficiency is very much higher. So the entire sustainability in transportation will definitely try to move towards this point, so that the cost, the damage that is caused to the environment is highly reduced. And this is also one of the study where the carbon footprint analysis is also done between all three types of vehicles. Yes, battery electric vehicles, it is fully propelled by battery pack. Hybrid electric vehicle, it has both the provisions. One is, I mean, it will have an engine also, and it will have a small battery also. And the IC engine vehicles, it will be only with propelled only with the fuel. So we could see that with the thermal coal fired power plant, the electricity produced from that power plant, we could achieve at least 26 tons of CO2 here. I mean, this is generated by a battery electric vehicle, but for IC engine vehicle, it is around 32 tons of CO2. So this 26 tons of CO2 will also be reduced if at all we replace this with renewable energy source. So this is one quick thing that I wanted to share. And yes, now we will just discuss about more on the battery technology. So what would be the requirements for a battery? So based on the how do I define the requirements for any battery pack? So I will for a vehicle, if it is a commercial vehicle, where based on the load that is required to be carried by the vehicle, I would define the requirement for the battery. I need a powerful battery. Definitely 400 volt battery will not be sufficient, which is enough for a passenger vehicle, will not be enough for a commercial vehicle. So based on the vehicle size, based on the usage, a couple of requirements I've just listed it down. So the vehicle range is one such parameter, safety is another parameter. Based on the body weight of the vehicle, the battery size could vary. The number of modules used in the battery pack would vary. And also we need to ensure the reduced, I mean, the charging time also have to be reduced. We cannot always do a slow charging for a commercial vehicle. So that is not always going to be a viable solution. So for that, we will always try to reduce the charging time of the battery. And also, of course, the sustainable battery technology is always an evolving process. And this is the current battery chemistry being used in most of the electric vehicles, where we can see this gives a good comparison between multiple chemistries used in the battery electric vehicle. And here we could see that these chemistries are compared against certain parameters. So these are the prime parameters based on which the permutation combination or the trade-offs have to happen between these parameters to arrive at a particular decision on usage of any of the uh, chemistry, battery chemistry. So here we could see energy density. It is like how much power is my battery pack able to hold at any point in time. So that is my energy density. What is power density? So power density is something, how much is my battery pack, how much power is my battery pack is able to give at a per unit volume, we could say. So that is what we call it as a power density. You can just have an analogy for this. Just take a small water bottle and pour all the water out. So how much is the force it gives? But if you take a bigger hose pipe, if you try to just put the water out of it, the force and the power with which the water flows is going to be a little bit more compared to the small water bottle. So that is what is the power density, how much power it is able to give out to the vehicle at per unit volume is what we call it as power density. And what is cycle life? It is like number of charging cycles that uh, uh, I can use this vehicle chemistry for my battery electric vehicle. Say for example, I have a battery pack. I bought a vehicle. If I'm able to charge and discharge for a large number of cycles, only then I'll be very happy as a customer. So here you can see that the number of charge discharge cycles vary with the different battery chemistries, and of course the LTO has the most number of charge discharge cycles, but the energy density here it is very low, and also the cost is very high, which might not be a viable solution for the customers to buy the vehicle, because considering the battery pack cost to be almost 40 to 50% of the battery electric vehicle. So considering all these things, for based on the charging cycle cost, the power density, energy density, most of the battery electric vehicle they use LFP, or they are looking at MNC also, NMC also now. And also you can see that thermal stability also is one important factor that has to be considered when we are talking, when we are looking at the battery chemistry. So LFP, it has got high thermal stability, whereas LCO does not have thermal stability at all. So what does it mean by that? So since the battery electric vehicle will undergo very harsh usage conditions, there are chances that at high temperature or when the overcharging happens, it will be, the cells might get into a thermal runaway condition, which is nothing but it will just get into a self-heating condition, an uncontrollable self-heating condition, and it will destroy the other cells also, and it will cause the battery fire to happen. So to avoid that, we will also always ensure that the thermal stability for a battery chemistry considered is always high. And also the recyclable and capacity retention, all these are like important parameters to be considered. Capacity retention is like after every charge discharge cycle, how much is the how fast it is able to come back to its original composition is what is the capacity retention. Because every time we do charged discharge, there are like, see, these are all okay, LFP, NMC, all these are battery chemistry. This is like lithium iron phosphate. So this is like nickel, manganese cobalt. So these are all different chemistry combinations used for a battery pack. And also like one point that has to be considered is like wherever cobalt is used, there are many harsh environment conditions that the mining people has to go through for mining these rare earth materials. So reduction of this particular metal in a battery pack is highly valued right now. So that's one of the sustainable point in the battery evolution. And this is one of the, the trend that I got from McKinsey report, that we could see a global increase of around 27% of increase in the battery requirement every year. You can see that the requirement here is like given based on the geography as well as based on the segment. If we see the segment, we could see that the mobility is going to be the highest consumer of these battery lithium ion batteries. So based on this, we could see we could understand how the market is going to navigate from 2022 to 2030. Also, like when we are talking about batteries, it involves a lot of components to be packed together to create a battery cell itself. So these are few of the components I wanted to highlight, like cathodes, anodes, separators, electrolytes, and cell packaging materials. So all these, as a whole, if the lithium ion battery trend is going to be increased, even this the requirement for these packaging materials, the materials, individual components that would be part of the battery cell is going to be increased at the rate of 70%, 17% per annum. And here also we could see that the cathode active material requirement is going to be the highest one. So this is where the market potential is more. And also, like as and when we use these materials, it is definitely not renewable in a source, material source. In that case, after the end of life of the battery, the batteries have to go under a recycling process to retrieve these materials so that the supply chain can continue without any issue. So otherwise, all the rare earth materials will get depleted from earth, and we will not be able to continue the battery manufacturing process at all. So that is one thing that I wanted to highlight here. And yes, now that we were seeing the battery cell components, now the battery cell components have to be packaged in certain form factor. What is a form factor? It is like the size and shape that I will give to a battery pack. So right now, these three are the famous types of form factors used across all the OEMs. You can see like Volkswagen or Benz or BMW. Most of the OEMs are interested in using prismatic battery cell. Why? Because prismatic cells, they use uh, they're very stable, first of all, and they use they're very good at volumetric efficiency, which means I can pack more energy in a small space itself, which means with the same battery module size, I will be able to pack more prismatic compared to cylindrical and pouch. So these are the bit of comparison that I wanted to show on the form factor trends. And also, like as I mentioned, which the prismatic is the one which is going to be increased. The requirement for this is going to be increased exponentially from 2024 to 2030 because of the volumetric efficiency. This is as per the European production capacities. Of course, it can be applied to other geography as well. And this is one type of battery which is very trending, and it is like it is of attention for now. It is produced by BYD, a very well known battery manufacturer in from China, basically. And he's like they are using lithium iron phosphate, which has got a very good uh, thermal stability, and it is very stable also. And also, if you could see this, they are not packed in modules. All the other types of form factors, they will have to be packed in a battery module, and then the battery modules will be connected together. Whereas the blade battery, if you observe here, each and every battery cell is itself is a module. It's like you don't have to have many number of connectors, or the number of connections between cells can be as minimum as possible. The wiring harness between the cells are very less here, which makes the maintenance also very less. If there is a fault in one of the cell, it can be easily replaced. So these are like few of the advantages of using blade battery, which I wanted to highlight. This is considered to be one of the stable form factor also. And these are few industry standards in India for ensuring the safety, both battery safety and the battery electric vehicle safety. And here, like you can see, like for the electric vehicles, these are the evolved standards. And for the traction battery alone, these are the battery specific standards. And for hybrid vehicles also, they have a specific industry standard. And these are like a standard for the charging requirement. And also, like, this is a pilot scheme which is in progress. So you can have a look at these standards and make sure, like, whenever you buy any of the batteries or for replacement purpose, or from while buying any of the vehicle from the uh, electric vehicle manufacturer, we can always look for whether they are following these standards before manufacturing those batteries. So whatever we have seen before, they are all standard form factors for a battery. The future is going to be completely flexible, which means we do have certain limitations by following these form factors, which can be overcome by following a different structural component itself. Say, for example, the objective is like to increase the thermal stability or the safety in battery usage, to reduce the weight of the vehicle, as well as effective usage of the energy stored in the battery. So all these three can be accomplished if the body of the vehicle itself can be able to accommodate some of the battery packs, right? So in that case, the batteries itself is created as a structural components for vehicles in a way that they will be able to actively participate in, renewable energy harness at all. So here you can see that the body of the vehicle itself is having a solar panel, and behind the solar panel, of course, the battery storage chemistry will always be there. The batteries will be there to store the energy. So these are like few of the future components. These are like batteries as structural components that will definitely come into market. And these are few other battery technologies like carbon nanotube electrodes, cobalt free batteries. Yes, as I was mentioning, cobalt mining is a very harmful process for the mankind. So that is to reduce that, cobalt free batteries are always encouraged. So that is one of the evolution that is happening. And also silicon anode batteries and battery extracted from even seawater is being tested. And also, like, the charging time for these kind of batteries are very less. It is like within 5 minutes they will be able to charge, and they will be able to give 500 kilometers mileage is what I was able to read from the uh, contents. And also there are sand batteries which are experimented, and solid state batteries. Of course, whenever we use batteries, it is like for every charge discharge cycle, if at all it is not maintained properly, there are possibilities of creation of dendrites. What are dendrites? Or they are all like growing um, uh, chemistry. So like it actually disturbs the existing chemistry. It will grow into the electrode in a way that it will create a short circuit between the anode and the cathode, such that it will trigger the instability in thermal conditions, and it will increase the heat because of this short circuit, and it will trigger that as a thermal runaway condition, and it will cause the battery fire. So to avoid these safety threats, some of the other battery technologies are being explored. One such technology is like solid state batteries, where the electrolyte, of course, it will not be a liquid electrolyte. It is going to be a solid electrolyte. And battery testing methods, yes. So what are battery testing methods? Before giving it to the market, each and every battery chemistry and the form factor have to be tested rigorously under all different conditions. Example, this particular graph clearly says that the SOC of the battery. What is SOC for a battery? It is the state of charge. Whether the charge, the state of charge is like how much is my charge right now in the battery. at any point in time, whether it is 80% or 100% or 0%. So this represents the battery SOC. The charge, whether at different temperature, how is my charge going to vary? The rate at which it is charging or discharging, that is also like would vary based on temperature, and also the capability of the batteries to hold the charge also would vary based on different environmental factors. One such important factor is temperature. So a study has to be done with the uh, rigorous testing done at different temperatures to understand how the charging behavior of the battery happens. And also like the state of health of the battery is also tested. What is state of health? It is like I mentioned earlier, we had the cycle times, right? If I can charge my discharge, charge and discharge my battery 100 times or 1,000 times or 10,000 times. So this number of charge discharge cycle will determine how many years I can use my vehicle. So if at all uh, this is a charge cycle degradation. If I do multiple times charging and discharging, especially when I do a fast charging, so in that case, the chemistry of the battery is going to be disturbed, which means it is like as and when this is kind of as and when we use any of the material, it will lose its original form, right? So that is what we call it as state of health. And the battery degradation that is caused by charging and discharging, we call it as cycle degradation. And there is something called calendar degradation. So for any material, if at all the material exists for a long period of time, it will lose its own original quality, right? So similar way, even the lithium ion batteries, when it is like when it is new, of course, it is going to be having a very good capacity to hold 100% charge. As and when the number of years or past, the capacity of the battery is also going to be reduced. That we call it as calendar aging. So combining both cycle degradation and calendar aging, the total degradation is of a battery is going to be this curve. So this will also be simulated in the testing environment for testing a battery. So based on these things, the battery will be rigorously tested under these testing methods, and then it will be determined whether it is a go ahead or not. So whether that particular chemistry and form factor combination is a go ahead or not. So here we do have like multiple types of testing. One is electrical testing to understand the electrical stability of the battery by measuring the battery voltage, internal impedance and internal resistance, like how far it will be able to withstand the temperature and all. And next is the compression testing. Of course, like whenever we use the mobile batteries, we could observe, right, as many number of charge and discharge cycle happens, the batteries will become bulged, right? Similar condition happens even with the batteries used in electric vehicles. So we will determine, this compression testing will determine how well it is able to accommodate that swelling. So that testing is what we call it as compression testing. And puncture testing or nail penetration testing will ensure if there is an accident or anything happens with the battery electric vehicle, in that case, uh, if there is any puncture happens inside the battery pack, whether it going to cause a battery fire, whether it is going to cause thermal runaway conditions. So that is something will be tested and verified using this puncture testing or nail penetration testing. And there is something called vibration testing. Of course, we will the vehicle has to undergo the harsh conditions and extreme weathers, right? So how is that the vibration stability is there? So that is something we will validate using vibration testing. And also, like you can see that the trend of this battery testing market is also increasing at a rate of 19.6%, the requirement for these. And we could see that the Asia Pacific region is what is going to be the major consumer for this testing requirements. And next is these, right, it's like till now we were just talking about the testing mechanisms. These will ensure that these are all preventive measures that we will do to ensure that there are no battery fires or any mishaps while handling the battery electric vehicle. What if something happens while using the battery electric vehicle? So how is that the existing mechanism, the under operation, the battery electric vehicle under operation, how is it protected? So there are certain management systems available within the battery electric vehicle that will continuously work around the batteries to make sure that the environment or the temperature or the required voltage flow happens in a stable way. So one such thing is like thermal management system, where we can see multiple types of cooling systems available. Like natural system, passive system is something that will use the vehicle motion itself to allow the air to flow through the battery, and then it will cool the battery as and when we use the vehicle. Whereas forced convection, of course, we will use the sensors and actuators to continuously monitor the sensing, and then we will make sure the cooling system or actuated. So these are a couple of other cooling mechanisms which can be implemented in electric vehicles, and that would vary based on the battery layout, structural optimization requirement for that battery electric vehicle, and as well as the control state strategies for these thermal management also would vary based on the battery electric vehicle requirement, whether it is a commercial, whether it is a two-wheeler, whether it is a three-wheeler or a passenger vehicle. And one important system that is going to help us in maintaining the stability of a battery system is battery management system. Of course, the battery management system, the modern battery management system will not only monitor, it will also actuate the required systems, be it a cell balancing system or be it a thermal management system, such that the battery is brought back to the stable condition. Mostly the stability perspective is like evaluated in terms of temperature and the voltage stability. Example, whenever we do charge a vehicle, what happens? The system will before actually charges the vehicle, the system will ensure that each and every cell will have the same amount of SOC in it. Say for example, if I have one battery cell having 80% SOC, another battery cell having only 20% SOC, and if I charge in that condition, the amount of current flow, if it is uniform across all the cells, then it is going to cause an overflow, current overflow, and it will cause a thermal runaway condition in that case. So to avoid all these things as a preventive measure, what battery management system will do, it will monitor all the voltages across all the cells, and then it will trigger the cell balancing mechanism, be it active or passive cell balancing mechanism, and then it will make sure that all the voltage levels across all the battery cells are equal, and then only the actual charging starts. This is with the cell balancing mechanism, as well as thermal management system will be actuated whenever the temperature goes beyond a threshold. So here we can see that these are the batteries here connected, and here like the cell monitor, these are the sensors which will continuously monitor for the voltage of the batteries, and then we have the wireless BMS as well as wired BMS. So one quick point I wanted to highlight is that in wireless wired BMS implementation, we might be having a lot of wiring harness required, which will also add on to the weight of the vehicle. Whereas if we implement wireless battery management system, we will reduce the wiring harness, as well as the maintenance of the battery pack is also going to be very easy. And if we are talking about commercial vehicles, wherein the number of battery module requirements is it's going to be huge. So in that case also, the number of wireless, if at all we are using wireless battery monitoring system or management system, the wiring harness will be highly reduced and it will be more efficient. This is one quick thing I wanted to mention, and I just took this architecture from Analog Devices. And this is like one quick system representation, how the battery monitoring and actuation happens. So here we can say that the These three are the parameters continuously acquired by the sensor system, and then it is transmitted to the safety protection system, and then the state it will be transmitted to the state determination system, and then it will be sent to the electrical control system, whether to actuate the cell balancing or not. And also, like, it will be sent, the same data will be sent for the thermal management system for further subsequent actuation on thermal stability. So this is just a software representation of it. And these are few of the SOCs I want to mention, which can be used for be it wired battery management system or wireless battery management system. Few of the SOCs I wanted to highlight, where you can use one SOC to connect with some multiple batteries. Like here you can see that 16 channel multi-cell battery monitors are there, which means one single battery monitor will be able to monitor around 16 cells. So these combinations based on the requirement we can use. And these two are like wireless battery management systems, which are transmitting the data with 2 gigahertz frequency. So these are the preventive methods again. So what is a battery fire? How does it happen? Right? So whenever the lithium ion cells, they have this dendrite forming, which leads to short circuits. It will heat up the battery and it will cause the heat to spread immediately to the nearby cells, and it will cause the fire immediately. So we have to ensure there are certain way of handling. If we do it properly, all these can be avoided. And also, like here, like one more reason is, like, there will be a tiny membrane called a separator between the anode and the cathode, so which is a very highly inflammable liquid, and if it is getting exposure to high temperature, then it will also create this exploding. And also, like yes, we already talked about thermal runaway. And also, like, if at all the flame ignites, it will definitely last for more than 2 to 3 hours. I mean, the based on the size of the battery, I could say. If it is a vehicle two-wheeler, it is going to be a lesser number of hours. Maybe for car, it is going to be larger number of hours, and it will not be immediately by foam extinguisher or something. We will not be able to immediately put it up. We might require large amount of water to put the fire down. So these are like few of the reasons why EVs will catch fire. Of course, the poor thermal management. If at all a battery system, if they don't have this battery management system or thermal management system, then we are at risk. Like, we have to make sure it is properly maintained. So here, like, if it is a normal fire, simple foam extinguishers will be able to put off the fire, because the only thing that we wanted to do is cut the fire from oxygen. So that if that is done, we will be able to quickly put off the fire, because oxygen is something that is going to fuel the fire. Whereas an electric vehicle, the fuel is there inside the battery itself, which will definitely, it'll not be these foam extinguishers will not be enough for putting off the fire. So the firefighters definitely need certain trainings and certain specific understanding of how to put these fires off. So these are like few of the aspects in which we can look at training the folks. And also, like here is one another point, where if at all we use salt water, it is going to be extremely dangerous, because it's a very good conducting material, and it could cause a lot of other worst situation. And this is something I wanted to show a quick pic of how the dendrites are formed within the lithium ion battery. You can see that the dendrite is like having, it is protruding through the electrolyte, and it is causing a short circuit, which triggers the high temperature because of the quick overflow of current, and then it creates the battery fire. And if it catches fire, it is going to be very, very, it's uncontrollable basically. So these are few of the uh, methods which we can follow to avoid these short circuits and overcurrents. So always try to get a certified electrician to install the charging device, and ensure that these engineers, they install with the proper matching requirements of the vehicle. So if at all the charging requirement and the actual battery electric vehicle which is going to use the charger, the charging or the charging plug point, if it is not matching, then it is going to cause the overcurrent conditions. It might also cause battery fire. And also like frequent maintenance on these electrical equipments, and also like using certified, the like all the equipments that will be used have to be verified with the regulatory body. So make sure you guys are looking at all these certifications before buying those equipments, even the cables, say. And also like we have to check the batteries or maintain the batteries also regularly. And also like we have to ensure that the battery management system and thermal management system is not faulty. And charging points are also like these are a couple of standards. It has to be complied with. Only make sure like only you guys buy the charging points, or use the charging points with these compliance. And also like the charging infrastructure providers, they will have to use the surge protective devices, so that, or even in the residential area we will have to use it, so that it will reduce the impact during lightning and other over voltage situations. So these are like a couple of other pointers that we have to consider while using the charging cables and other equipments. So we have to make sure like these are a couple of again standards that or compliances which the equipments or the cables have to comply with. So make sure we get a proper set of the cables and equipments. And of course the thermal runaway also we have discussed multiple number of times. Like the always the best practice is that we should never charge the battery more than 80%. Also we should never deplete the battery below 20%. So always try to maintain the battery state of charge between 20 to 80%, so that it will last a little bit longer. And also always slow charging is what is always recommended for a stable battery behavior. If at all we do more number of fast charging, it is going to change the chemistry, internal chemistry, in a way that the original SOC or the capacity is not retained. So that will also cause the battery degradation to be a little bit faster, which means if at all the battery the last for 10 years, it might last only for 5 years. So that much impact it would cause if more number of quick charging or fast charging is done. So these are like a couple of summary points I wanted to highlight. So ensure that these standards, all the equipments and the EVs, all the batteries for replacement, whichever is bought, complies with the safety standards. And also like necessary insurance have to be taken, because it is not just the batteries, it is like how the batteries are handled whenever there is a breakdown, how it is stored, how the vehicle is stored. That is not known to everybody, not known to or not trained to all the service centers. Only the battery electric vehicle certified professionals will be able to handle it properly. So we have to make sure like to take proper insurance and add-ons required, so that we will not get into trouble during these situations. I think there's quite a good amount of discussion happened on one of the insurance committee meeting. Probably you guys can have a look at that video also for more information on insurance. And also like always maintain, I mean, do a high voltage component inspection uh, every at a regular interval. This kind of a periodic maintenance, we can say. Yes, I think I'm done with my content. Probably we can discuss on the Q&A. If you guys have any queries on any of these market components, you can raise it or put it in the chat. Ajita, you can take over. I think I'm done with the session. I hope it has benefited for most of the participants. Please feel free to connect with Ajita for any queries
Thank
so that she can direct to the right person. Yeah, thank you.
you. So thank you all for joining us today and for your active participation. Special thanks to speaker Ms. Kalaivani ma'am. We shared
And
a
can we have a couple
great
of words?
information about we have.
Yeah, Ajita, can we have a couple of words from Henry? Can we invite him?
Sure.
Yeah.
Hey, yeah, I mean, thank you guys. I mean,
I would like to so please.
yeah, I mean, I think it was a good overview of.
So please share your insights with into.
Yeah, can you hear Ajita? Are you able to hear me?
Yeah, it's a bit
Yeah, so
feeble.
I'm
Okay. Well, I just wanted to thank the
not
presenter and the participants. It was quite a good overview, the general overview of how the batteries, the different chemistries, and how the trends are going on. The one thing that I would also like to add is there are additional chemistry trends that's coming in, which is the LMFP, which is the lithium manganese ferrite phosphate. This seems to be quite a good chemistry that's coming in. I'm sorry, I'm not sure why they. So I just wanted to add a couple of things for the questions. So someone asked, what are the different abbreviations of the chemistries? I just wanted to add, like, when you look at the chemistries, let's say you Google and look at what is an NMC or so, you are going to see an additional number beside it. So let's say NMC 811 or NMC 333. What that means is, for example, if it's NMC 811, it means 80% of nickel, 10% of manganese, 10% of cobalt. If it's NMC 333, it's 33% of nickel, manganese, cobalt, all 33%, right? So these variations of the chemistries are also going to impact the potential difference and the capacity of the battery. So I just wanted to add that. I'm just looking at the chat if there are any additional questions. Kale, if you want to take any of the questions, you can. I will just quickly add from what I see. There was an interesting question about the amount of lithium source. Actually, there are two things, right? So one, lithium is an element that is available plenty. It's like asking, is salt going to be taken away? You know, we all eat salt every day for cooking, right? It's like asking, will salt get over in the world at some point of time? It's like that. Lithium is actually available quite a lot. But on top of it, what's happening with the mandate is there are regulations to force reusing of the lithium. So the recycling as of today is quite successful in recovering even up to like 92 to 96% of lithium from the battery. The economic viability is a different question, but technology ways we are easily able to reuse. In some countries, actually, especially in EU, in all the countries in EU, it is mandated that every new battery from 2027 have to have a certain percent of reused lithium. So I think the supply is not going to be a problem. Transient, there is another question on transient effects on batteries. This is an excellent question, actually, because the steady state and transient behaviors of the batteries are going to be different. How is the question? So the way the discharge is going to happen, it's based on what you call as an OCV curve, like an open circuit voltage curve. You can Google that and you will see that the open circuit voltage curve is different for different chemistries. Some of them are quite easy. Ideally, you want like a linear curve, but that's not the case, right? So for lithium LFP, which is one of the popular chemistries, it's more flat. So when there is going to be discharge done at different C rates, the way the battery, so the way the battery degrades is one, and how the battery is an exothermic reaction, right? Whenever you charge or discharge, how the thermal properties happens is the second point. And more interestingly, the transient conditions are going to force certain intelligence from the BMS as well, the battery management system. So transient conditions are interesting, but because most of the time the cars are going to be in transient conditions, it's not going to be a steady state charge and discharge, right? So that's more for your cell phones. So when people compare and give you logics on how the behavior of a cell phone is and the car is, you can't compare them both. They both have very different level of intelligence, and they both have very different type of chemistries as well. So in short, when you do a transient condition, thermal properties, life cycle properties, and the amount of intelligence required to control, these are all quite critical. So yeah, Kalai, do you want to add a few things? I just went through some of the questions on the chat. I hope my voice was not breaking. I have no idea. Hopefully it was legible. Yeah, okay.
Yeah, I was about to say about the same thing, like having the proper BMS associated with any battery will be able to manage this transient condition. Of course, the battery electric vehicle, it will have a continuous transient states, even during charging also. So that will definitely require continuous monitoring of these three parameters, the temperature, current, and voltage, and based on which the actuation of cell balancing and thermal stability will be done. Yeah. If there are no other questions, probably we can wind up. Yes, over to you, Ajita.
Thank you for sharing the valuable insights. To thank Annie ma'am. So if there is any other feedback or follow-up questions, you just can ping me. I'll just drop my email ID in this chat box. So you can email me and I will share you any other further details also. We look forward to welcoming you for all other future events. And thank you all. Thank you, sir. Thank you, ma'am. Thank you.
One point I wanted to highlight, we do have a SICKI EV page as well as SICKI the official page in LinkedIn, where all these videos will be posted. For any queries, you guys can post there also. It's like once the video, the recording is done, it will all be available in the platform.
Yes, even in YouTube also you can video. So I will just share the links also, ma'am. If anyone asks, we will share the mail or what any other thing. my can check with me.
Sure.
later.
Yeah, thank you so much.
Okay, thank you, ma'am. Thank you.